So to make these blades, you make a mold. You basically split this blade down the middle here, and you have the one side of the blade on this mold, and the other side of the blade on this mold, and then you put a like a shellac for your nails almost down, and that's the gel coat, and that's where your paint is as well. Some people paint them afterwards. It's sort of all depending on what, who you are, if you're Vestas or Siemens or GE. But then you start laying up fiberglass and carbon fiber, and once you've laid that all up, it's wet, just like when you have to patch a hole in the drywall. It's a fiberglass mat that you're using, and you lay that up and you press it down, and you have these spars on the inside, just like an I-beam, that makes sure that this blade, which we just talked about, right, it's 150 foot long. Some of them 300 foot long. If you have to hold on to that here, it takes a lot to hold on to that blade out there. You have to have, they call it a spar cap. You have to have these structural pieces inside of the blade to make sure that they don't flex too much. They have to flex a little bit, because the higher the wind is, you want to flex that blade backwards just a little bit, so that the load, if there's a gust of wind, that load is absorbed not by just speeding up the rotor, but by flexing the blade back. Because when that load then retracts, when the gust is over, the blade will want to come back and want to speed the rotor up just a little bit, and then we're ready to harness that wind out of the turbine as electricity, instead of having to put the load from here down to the ground where it's wasted. We pull it up in rotational energy instead.